Okay, so here we have the frustrum of a pyramid, and so that's just the pyramid with the top cut off. They don't say it in the question, but we're assuming that the point of the pyramid is directly above the center, right? So that we have this kind of symmetry, this uniformity to it. And we're told that the base of the frustrum is 19 by 19. It's a square, and the top is 5 by 5. It's also square, and the height is 15. And so we want to find an integral that gets this area. And so because the height is from 0 to 15, or from because the height is 15, we're going to integrate from 0 to 15. And if you can see, there's this y in here. I did in pink to show that it's sort of related to this red cross section, but this is the height y at which that makes it worse. This is the height y at which the cross section is cut. So we're thinking about this as at every level in between 0 and 15, we stop at this point. We stop at this point y, and then we slice it, and we get this cross sectional thing, which we then give this infinitesimal width of d, or height of dy. That's what that kind of three-line ghostly side thing is meant to indicate, is that it's given this, and it should have probably jutted out a little bit, because this is actually going to be like a cube or a square thing. Yeah, that's how it should have looked from the beginning. There we go. I spent like 20 minutes making this thing, and it's finally, there we go. Okay. And so the idea is that we give this thing this like little bit of height to sort of drag it into the third dimension, this infinitesimal height, which I'm going to get this right, I promise. There we go. We give it this infinitesimal bit of height, which is the dy, and so now it has this infinitesimal volume, and so we sum up. So if we take the sum of all of these things, we actually get a volume. We get the volume of this frustrum. But the idea is that we're summing up these infinitesimal volumes of these square slices. So we need to know what is the area. We need to know there we go. We need to know the area as a function of y. We need to know the area of this square as a function of y. We're going to multiply it by the dy, but we have to know its area at the particular height y. And that's the whole key to all of this. This is typically the hard part of these problems, is figuring out what the cross-sectional area is. And in some it's harder than others, but in this one it's basically the whole game. So the insight that allows us to do this is that because again, assuming the apex is directly above the center, right, we have this not only continuous but uniform rate at which the size of the cross-section is changing. Right, if you look at the edges of this pyramid, right, they're lines, they're straight lines. They all have the same slope up. So this thing, the height or the width of these, length, width, which are the same, the side length, and therefore the area is all varying at the same rate. It's changing at the same rate the whole way through, because these are lines. It's guided up by these lines which have a constant slope. And so that means, and this is the key to the whole thing, that the average change, how much it changed from the top to the bottom when it went up those 15, is going to be the same rate at which it's changing at every level. So it started out. So let's set this up. At the end, so the last height at the top here. So you can think of this as the rate of change function, the average rate of change, f of b minus f of a over b minus a. The b minus a is 15 because it went up 15. F of b, so at the end it was 5, and at the beginning it was 19. So we get 5 over 19, and then divided by 15. That is the rate at which it's going up. That's the rate at which we go up. And this has to be the rate at which it, if this makes, hold on, let me just compute this. This is negative 14 over 15. This is the rate of increase here. So that means that the side length of this square is going to be 19, right, 19, the amount that it started at, minus how much it's changed by, right? Minus how much it's, because this is a rate of decrease. Negative 14 over 15 is a rate of decrease. So it's minus 14 over 15 times y. And if this seems a bit weird, think about what happens when y goes from 0 to 15. When y is 0, this is 19. This is the base side length. When y is 15, it cancels, and we get a negative 14, and 19 minus 14 is 5. So it's that top side length of 5. And from there, it's just changing linearly, as we can see with these sides being lines going up from the bottom to the top. It's changing linearly from 19 to 15. So this is the cross-sectional area that we're after. This is A of y, the cross-sectional area. So we look at our integral, our general form of the integral, so 0 to 15, where I'm integrating from the bounds of integration. There's going to be a dy, which drags this, gives this infinitesimal height, which gives this area, the cross-sectional area, infinitesimal volume. So I can sum volumes, and then I'm multiplying by this, the cross-sectional area. And so this turns out to be, I can do it a little bit nicer, 0 to 15 of 19 minus 14 over 15 y squared dy. And this, I mean, you can do this by a substitution. You can also just FOIL this out, and it's a little bit computationally more messy, but also kind of more straightforward. If you don't like U sub, or if you'd rather not do U sub on tests, you can just FOIL this out, right? It's become 14 over 15 y squared minus 2 times 19 times 14 over 15. I'm not going to try to do the math. Plus 19 squared. And then you just integrate that fundamental theorem of calculus, part 2, evaluate it at the endpoint, and so you anti-differentiate, and then plug in 15, plug in 0, subtract. So, and you don't have to worry about the constants. So if you're solid with doing definite integrals, this is just a definite integral of a polynomial with a quadratic with gross coefficients. And that by the way, this should be most of the marks getting to here, right? If you once you evaluate it. So if you're like really pressed for time on test and you're like, I don't know if I can do this, you could just leave it here and probably get 75% of the marks. But this is really not so bad if you're okay with doing some quick arithmetic, some quick multiplication on the side. Then this is really straightforward. It'll be gross, but it'll be a number. So that is how we get the volume of this annoying thing.